All right, thank you, Daniel 777-333-777 for this great question on the homework help subreddit. Question reads, Town A and Town B were 318 kilometers apart. Erika traveled from Town A to Town B at a constant speed. At the same time, Wayne traveled from Town B to Town A at a speed 21 kilometers per hour faster than Erika along the same route. They passed each other after 2 hours. How much time did Wayne take to reach Town A after he passed Erika? Give your answer in hours and minutes. All right, so let's draw a little picture of this. So we have Town A, we have Town B off in the distance, and there's some path in between them. We don't know what the path is, but we know if you travel along that path, you will travel a distance of 318 kilometers per hour. I'm sorry, 318 kilometers. Okay. Erika starts here. She starts at Town A. And Wayne, actually maybe you won't be able to see that, Wayne starts at Town B. Now Wayne's path direction along the path is back towards Town A, and Erika's direction along the path is towards Town B. All right, that's important to notice. So let's take Erika's direction to be positive and her speed then to be positive. So since Wayne is traveling the opposite direction, his speed is going to be negative, okay? So that's our picture. That's what we're dealing with here. Recall that we have the form of the equation of a line being y equals mx plus b, okay? Now this is nice because we're told that Erika's rate of travel, her rate of change of her distance from Town A is constant. And here we have a constant rate of change, okay? I really like this type of problem. It's a nice introduction to physics type problems, and it's really easy to understand. So instead of using x as a variable here, we're going to use t because the thing that changes is time, okay? So everything is going to be a function of time. Time is the independent variable here, okay? Now b would be our y-intercept, but here it's going to be the distance away from Town A that we start. We're gonna say that y is equal to the distance from Town A. Y is the distance from Town A, okay? So for Erika, we are going to say that y is equal to whatever Erika's speed is, we don't know, times the time she traveled at that speed. Now she starts 0 kilometers from Town A. So for her, b is 0, but we don't need to write that. All right. Now for Wayne, he is starting at 318 kilometers from Town A, and he goes backwards. He goes towards it. So I'm going to give him a negative speed, and his speed is 21 kilometers per hour faster than Erika's. So we said that Erika's speed is m, and his is 21 faster. And then we're going to multiply that times the time he's been traveling, okay? So we're all set up to start our problem. Now we need to solve for this m somehow. Thankfully, they gave us some data to do it. They said at time equals 2, at 2 hours of travel, we know that Erika and Wayne cross paths. So if you're crossing paths, that means and you're on the same route, that means you're the same distance away from A. And since y is the distance from A, we can say that they have the same y value. Okay, so at t equals 2, their y's are the same. And that means they're equal. So since Erika's y equals mt, and Wayne's y equals 318 minus the quantity of m plus 21 times t, we can set them equal. And it's only true for t equals 2. So let's sub 2 in for t, and then we're going to solve. Okay, so we put 2 in for t. Now I'm going to divide both sides by 2, over 2, over 2, and we get m equal to 318 divided by 2 is 159 minus m plus 21, which has a factor of 2 next to it, so I'll just, we'll cancel here and here, and this went to 159, okay? So we're left with m equals 159 minus the quantity of m plus 21. Now there's a little imaginary 1 here, and I'm going to distribute that to both of those guys, okay? So this is going to give us m equal to 159 minus m minus 21. Okay, so we are going to add m to both sides, which gives us 2m equal to 159 minus 21. 159 minus 21 is 138. Now we divide both sides by 2, divide by 2, and this tells us that m equals, it's going to be 69. M equals 69. Okay, cool. So here we have an m, and here we have an m. So let's plug in for those two m's. Okay, we'll get 69 times t. And then here we've got 69 plus 21, and this is just equal to 80, 90. Okay, so this is going to become 90t. All right, so we don't need this stuff anymore. So we used that understanding they were passing each other t equals 2 to solve for their speeds, right? And now the question is, how much longer after they passed each other does it take for Wayne to get to town A? So if Wayne is at town A, his distance away from town A is 0, okay? So we can set his equation equal to 0, and then solve for t, and that'll tell us what time his distance from town A is 0, okay? So I'm going to add 90 to both sides, and I'll get, 90t to both sides. Actually, maybe I'll just write that since you guys are learning your algebra now. We're going to add 90t to both sides, okay? And we'll get 380 equal to 90t. And then I can, this is the symmetric property of equality, so 90t equals 380. And then I don't do math in public, so let's figure out what is 380 divided by 90. Okay, it's 4.222 repeating. So this happens, it takes him a total of t equals 4.222 repeating to get to town A. Now, let's pay close attention to see if we've actually answered the question. The question says, how much time did Wayne take to reach town A after he passed Erika? Okay, so we have not finished. This is how long it takes him to go from B to A. But we don't want to include those first 2 hours. So let's just subtract 2 from this. And then we get t, so we get 2.222 repeating hours. From the time that they passed, that's how long it'll take him to get all the way to town A. So we want to figure out what is this in hours and minutes. And that's the last bit. It says give your answer in hours and minutes. So the whole number part is hours, so 2 hours. But we need to figure out how much is 2 repeating equal to in minutes. So this is 2.2222 hours, and we know that 60 minutes equals 1 hour. And so I'm going to divide by 1 hour. And I'm going to divide by 1 hour, okay? 1 hour. And so this becomes 1. So 60 minutes divided by 1 hour equals 1, okay? So I can multiply by that. If you multiply by 1, you don't change anything. So I can multiply by this, 60 minutes over 1 hour, okay? And hours cancels. This is hours. Okay, hours cancels just the same as if it were a factor. And then I get 60 times 0.22222 minutes. Okay, so I'm gonna, so we got, oh, my thing's dying. What is this? .22222 divided by, or times 60. Let's see. Okay. Sorry, it's kind of ridiculous. My keyboard doesn't seem to work when I'm in full screen. So this is 13.333 minutes, so 13 1/3 minutes. All right, so our final answer, sorry, this is kind of ambling, is 2 hours and 2 hours and 13 1/3, which is, we can, they want it in minutes, so minutes. That's our answer. So I hope that helps. Hopefully it's not too confusing.